Alright, so here are the notes for 7.2, inverses of relations and functions. What we want to do here is graph and recognize inverses of relations and functions and find the inverses of functions. This is really not a very hard section, it's actually a very short section, so you'll kind of see what we're doing here. To graph an inverse of a relation, reflect each point over the line y equals x. So, if you draw the standard, the parent function for a linear graph, that diagonal line y equals x, you're flipping every point over that line. All that really does is switch the x and y value. So keep that in mind. Basically, if you're looking at a table, you see all the x points and the y values. You switch them so that the x's become the y's and the y's become the x's. That basically will give you an inverse. So, for example, here's a function, or here is just some points for a function, and then you've got these points, and the next one I'm going to show you is the inverse, and all I'm going to do is switch them so that instead of being 2, 0, it's 0, 2. Instead of being 4, 1, it's 1, 4. Instead of being 5, 2, it's 2, 5. 6, 4 becomes 4, 6. 7, 8 becomes 8, 7. And then look at the graph. Okay, so I'm going to show you the original in yellow, and I believe the inverse in orange. So you see here I'm graphing those 5 points. Now I'm doing the inverse, and the blue line right there is y equals x, and you can see how it looks like they're flipped over, one reflected over the other. That's all that is. And then let's look at the domain. The domain for the first one was from 2 to 7, and the range was from 0 to 8. Now notice the domain and range for the second one. The domain for the first one, or for the x's, is 0 to 8, and the range is 2 to 7. So notice how those flip-flopped also. So like I said, this is something that's fairly easy, shouldn't be that hard. Okay, so now let's look at the inverse relation or functions. If f of x is considered a function, okay, so we say f of x is equal to something, then f to the negative 1 of x, which is actually the way we would say that is f inverse of x, is the inverse. So this f negative 1 is f inverse of x. So it basically is saying the inverse of x. And what we do here, again, is think of it like this. If I have that function right there, f of x is equal to 2x, then I should know that the inverse is equal to x divided by 2. The way that I get that is by changing f of x to a y, then switching the x and the y, and then I need to solve for y. So how do I solve for y? I've got a 2 times y divided by 2. So y is equal to 2x divided by 2, and then I can change this answer right here back to f of x, but since it's the inverse, I say f negative 1 of x. So f inverse of x. Okay, some more examples. Don't know why it switched out like that, but there you go. X plus 2/3. Okay, again, I'm going to change f of x to the y. And again, you can automatically make that switch where you just say the x and the y are switching because you're thinking of f of x as the y. Okay, I'm adding 2/3. The opposite of adding is subtract 2/3. So I have x minus 2/3 is equal to y, which now that since y is by itself, that's the inverse. And so that means f negative 1 of x is equal to x minus 2/3. Another example, f of x is equal to x divided by 4 minus 5. Again, change it to a y, switch them, and then solve. Now again, keep in mind how you've always done your operations. First thing you should do is take care of the plus or minus. So I'm going to say the opposite of a minus 5 is plus 5. So I have x plus 5 is equal to y divided by 4. The opposite of dividing by 4 is to multiply by 4. So I'm going to multiply both sides by 4. And you don't necessarily have to say distribute. You can leave it as 4 parentheses x plus 5. You could distribute and say 4x plus 20. But that's fine. I mean, I'm going to leave it like that. If you wanted to to write it as 4x plus 20, that's fine. But I'm just as happy with this answer right here. Okay, last example. I wanted y'all to see the graph of this. So f of x is equal to 3x plus 6. If you take the steps to work this out, you would find out, go ahead and take a couple of seconds or pause it right here to figure it out. But once you do graph it or solve it, you should get something like x divided by x minus 6 over 3, or preferably 1/3 x minus 2. Okay, the line you see right there is the y equals x line. That's the line that it would be reflected over. Okay, and I'm going to draw the first one in blue, or obviously the inverse in blue, and the regular function in red. And you can see they kind of flip-flop over each other. So this is the idea. The main thing you need to make sure you can do is that you can still switch the x and y and solve for y. Nothing that should be all that difficult, and that's pretty much it for this section. Thank you so much.